In this video, we'll be teaching you about stoichiometry. Stoichiometry can be used to predict the amount of products, among other things. By the end of this video, you will know how to do unit conversions, determining limiting and excess reagents, and calculate percent yields. Here is our key terms page.
An important part of stoichiometry is limiting and excess reagents. A limiting reagent is the reactant that limits the amount of a product produced. The excess reagent is the reactant that remains after the reaction is completed. This is important because it allows us to calculate how much of the excess reagent will be left at the end of a reaction.
Okay, so today we're going to demonstrate the use of limiting reagent and excess reagent in real-life situations. So as you can see, I have 4 pieces of bread, which will be my limiting reagent, because we all know that 4 pieces of bread can only make 2 sandwiches. 2 pieces of bread per sandwich. Okay. Peanut butter will represent my excess reagent, because I have enough peanut butter in here to make 3 sandwiches. So I'm just going to make my sandwiches really quick. Okay, so now I take my other 2 pieces of bread and make the sandwich. So as you can see, my limiting reagent, the 2 pieces of bread, allows me to make only 2 sandwiches, but I had enough peanut butter to make 3 sandwiches. So my excess reagent would be the leftover peanut butter. Now that's some tasty learning.
The next part of stoichiometry is percent yields. To find the percent yield, which is just what percent of the product fully reacted, you must take the experimental yield divided by the theoretical yield, then multiply it by 100%. The theoretical yield is the maximum amount of product that can be produced from the given reactants. The experimental yield is the amount of products formed in the lab. The experimental yield is often smaller than the theoretical yield, because in the lab not every single molecule fully reacts. Sometimes, though, due to the experimental error, it is also possible that it is larger. For example, in Belo's video, the theoretical yield of the peanut butter may have been 2 millimeters of peanut butter on every inch of the sandwich. The actual yield would be the amount of peanut butter he actually does put on the sandwich.
Alright, here we have the practice problem. Please pause the video and take a few minutes to solve it. Alright, we'll start off with A, and we have to write a balanced chemical equation. Magnesium arsenide becomes Mg3As2, and sodium chloride becomes NaCl. This is a double replacement reaction, so the products are magnesium chloride and sodium arsenide, and it balances out to 1,632. Alright, next we have to find B, but we can find B while doing C, so we'll skip over to C. Alright, we will start off with 2 unit multipliers, starting with the givens, then we have to go to the products. We'll start with 850 grams of magnesium arsenic and go to molecules of magnesium chloride for 1, and start with 327 grams of sodium chloride and go to molecules of sodium arsenic in the other. Our answers for these come out to be 6.9, 6.9 times 10 to the 23rd 10 to the 23rd molecules of MgCl2, and the other one we get 1.12 times 10 to the 24th molecules of Na3As. So those are the answers for number C, if you were listening, but we still have to find the answer to number B. So we'll do another unit multiplier, starting with 327 grams of sodium chloride and go to the other product. Note that this can be done with either reactant. So for this unit multiplier, we get 1.68 times 10 to the 24th molecules of Na3As. And so that is a lower number than our 6.9 times 10 to the 24th. So our answer for the third unit multiplier is the limiting reagent, and our answer for the first unit multiplier is the excess reagent. It's a limiting reagent because it produces the lesser amount of product, and the other one is the excess reagent. So now we have to go on to D, the last part. We'll do 4 unit multipliers to find this out. To find out the moles of each product, we use magnesium, arsenic, and chloride to find out the actual yields of the products. So we have, I'll just fill this in. It's 850, 1, 222.74, 3 moles, and 1. That equals 11. Next one, it is 327. We have 58.443, 1, 3, 6. That equals 3.18. I'll just write in the other ones. That one equals 7.6. That equals 2.12. All right, so we have all those, and then those are the moles of each product, and then we have to find the actual yields, and we'll use the limiting. Well, scratch that. We find the actual yields. So we'll multiply the 2 lowest values by 0.65 because of the 65% yield, and we'll get our final answer. So our final answers are 2.07 moles of MgCl2 and 1.38 moles of Na3As. That's that.